Hi there, welcome back to my channel. Today I will be showing you how you can stitch images in Python. And so we'll have some input images. In this case we have 3 images, but I'm showing 2 here. We'll have this image with this little dome here, and the second image with the dome a little bit in the middle. And so we'll have more area here that is not present in this image. And in this image we're seeing some stuffs here, like these 2 human beings, and it's not present in this image. So basically you stand at a point and you take image of the scene, and then you rotate. Try not to translate, just rotate, and take the second image. You also want homogeneous light, so we don't want change in lighting between the 2 images. If not, once you stitch them together, you observe that you're having there'll be a translation. Basically you have a gradient in your lighting. And in terms of professional kind of like shootings, you don't want those kind of stuff to happen to your images, so those are stuff you need to take into consideration. And so if you have 2 images, you could stitch them together so you have a panorama kind of view of the scene. So that's what you have here in the final one. This one is a raw stitch, so basically if you look closely here, you see the point that the images were stitched. So basically you used correspondence that identify features in the 2 images that are the same, and then you could use the extrinsic to like reposition them and then you match. But there is also a method or functions in OpenCV that does this almost automatic for you. So I'll be walking you through the process of getting this done. So again, we have an input image, we'll stitch them together. We'll have this raw image, the raw stitch image. On this raw stitch image, we'll find a bounding box that is minimum. That's like a box, a rectangle that will fit into this image without bringing in this no data region. And then if we apply the max onto this raw, then we'll get our final. So this is our final. The image is longer, so we're seeing more stuff compared to any of these 2 images. And yeah, it looks just like the normal panorama image. So with that much, let's go straight into getting this stuff done. So I'll zoom in a little bit here so you're able to see what I'm writing. We'll start by importing the packages that we need. These are the packages. I believe you're all familiar with this. If you're not familiar, please check my previous videos. I'll explain what each of these libraries is doing. And at the start, I don't want to use the normal get and contours or the contours in Matplotlib. So I've defined a function here. I want to use OpenCV for most of my stuff since I'm focusing more on computer vision projects. So I have this function here. I will explain it more when I'm using it, but basically it extracts, use some threshold. So it provides like a binarized image to read, and then it uses a threshold value, which is 0 and 1 since it's binarized. Then it picks the true values out of it. So basically you get contours from your image, the image you feed it in. So let's run that. And then next is to load our image. So we have a folder here called data, and in this data there's something called unstitched images. So in these unstitched images I have a few images, in this case 3 of them, and this image is an extract from a video that I recorded a long time ago in Oregon. So this is the video. It's a drone footage. So I flew at the Cannon Beach. So this is a Cannon Beach, and then I get this. Basically I had the drone hover and then went around and then get this set of images. So I'm extracting 3 frames from this short video to demonstrate this. If you need this video for practice, just comment video and I will send it to you, or you could just comment video and also send your email because I need something to send it to you. So with that said, we have our data. Our data is on stitched images, which are just 3 of those images, and I call stitch 5 to stitch 9. And so here we're just pointing our program to the path where these images are. They're in the data and in this folder, and these folders, all of them are PNG, so we could easily use globe to extract all of them, and here I'm sorting them so that they're arranged in a proper order. Scene started here, and then this is the middle, and then this is last. And so once we have once we have like collected the path where these images are using this stuff here, then we could load those images. And again, one of the conditioners here, you want to have more than 2 images. So when you stitch an image, you cannot just stitch a single image. And so we just have this conditioner here that makes sure that you have more than 2 images. So if this folder has just 1 image, then you get an error message that will tell you that you need at least this. Again, this is just to allow you to see how this sort of like how you allow the program to do much of the work for you, so that you have less of like debugging to do. So this is how you do the error message, basically checking the conditioner. So checking the length. The length is just checking how many files are present in this particular listing or collection that you got from this file paths. If it's greater than 2, again, if there are more than 2 here, this will, for example, if you list this here, it will be 0, 1, 2, so you have 2 on there. So if it's more than 2, we are good to go. So with that said, let's proceed. And then next we'll load each of the image. Again, we're just using OpenCV.imread, and then we'll just provide paths. So it's basically we're slicing in this path. So among these 3, we'll pick the first one, second one, third one. That's what this loop is doing here. And then we'll have the information and red as colored, because we're not providing anything here by default. Since it's a colored image, you load as colored image. And if there's nothing in those folders, so if, for example, the path, if this image could not find anything, if there's no data, basically it should tell you that yeah, your path has issue or something. So this is another way of like easing your debug steps, so you know exactly what is failing. And then we'll just append this back into this list of images that were created initially. We also want them to be in lists, just easier to manipulate in this case. And then again, while we're loading it, we are also like visualizing it here. So if I run this, it should basically load all the images. So these are the 3 images that are listed here. This is the image 1, this is the image 2. We have this one. This one has nothing, it's just going all the way to this other side. And then it has this in the middle. Okay, so now we've successfully loaded our 3 images. And again, if you check here, you have data, you have numbers there, you have list of lists. So there are 3. We sort of like appended 3, so that's it. So you have 3 of those images, and they are unsigned integer 8. Okay, so what's the next step? The next step is to stitch them together. Now we have those, you have the data, we want to stitch them together. To stitch, we're going to use an object in OpenCV that's called teacher's crate. So there's a teacher, there's a teacher crate. So basically we initialize this object and we'll call it as teacher. And in this teacher there's a stitch. So we'll do stitcher.stitch, and then we'll provide in the images. So remember, we'll have these images here, the 3 images, we're feeding it in here. And the status tells us if it's okay, if it's able to like successfully stitch it or not. So if it's okay, we'll check the status. If it's okay, then we'll proceed basically. So we'll do that, and then we'll get a stitch. So basically to stitch all of them together and then return it back to you in this variable here, stitch. And we could visualize this. It's an image that has already been stitched. So it's basically in the background here, it's like identifying correspondence in the images and doing some string translation and doing some homography basically in the back end. And at the end of the day, it's able to stitch them together and speed out the final image that is stitched here. So if we run this now, and again we're saving it, so this is how you save image. Just do cv2.imWrite, so imWrite, image write, and then you provide in the name that you want to call it. And in this case is where our script is. You could put it back to where your data was, and then the data that you want to save was save the raw. So it's basically this data that we're fitting in there. And so this is how the stitch look. We have some information coming from here and another information coming from here, but it doesn't look so great. I mean, you wouldn't post this on your social media if you want to post a panorama kind of image. So the next step will be to clean this up, basically fitting the minimum rectangle or the maximum rectangle, depending on how I want to explain it, that will go through this image. So we want usually images are rectangular, so you want to fit a rectangle here and then keep all the information within that and then throw away what is outside. So that's what we'll be doing next. So to do that, first we have to add a border. So basically find contour around this image. Since we know that these are all zeros, if we find where stuff are greater than 0, we could find a contour basically. So we're trying to add our border. We add the border, and so it's just an extension of this same data that we have here, but by 10 pixels, so we have all blacks. And once we have that, then we could do the thresholding. And again, it's nothing by just fitting in your stitch image. First you have to convert it. So first you convert this image to grayscale, and then because for you to use this threshold you expect like a single channel, so I mean you could also slice this to fit it in here, but this is an easy way of doing it. Just convert it to grayscale, and once you have your grayscale, then you could binary use this and threshold binary, basically where there's data and where there's no data. So where there's data will be 1, where there's no data, this black point would turn to will basically go to zeros. So you have this mask. So this mask is just corresponding to this stuff here. So basically we're just finding where you have data and where we don't have data. You have many ways of doing it. Feel free to do it the way you're familiar with, but that's one way of doing it. And so once we have this mask, next is to work on getting the region the largest contour, which is based on this guy here. This largest contour work out, or basically if you want to fit a rectangle to your largest contour, that's how in terms of programmatically, that's how you get to like figure out where the rectangle will work out. So you find this contour, and then you want to find the biggest rectangle that can fit into your contour. So that's the technique that I apply down here. And so just fitting a bounding box to your rectangle. If you run that, then you have the finalized bounding box. So this is like the initial one, but to get the finalized one you have to erode over time until when you get the perfect size, and you just do that until when you have like your non-count 0 becomes greater than 0, and then once you just achieve that, then you get this sort of stuff. So now we moved from this guy is just sort of like started from this edge, and then it's like eroding, like going down until when this region in this rectangle does not have any 0 that's coming from the contour that we found, or there is like no data from the stitch image that is 0 that's appearing within the region of this. That's just how you implement it. It's nothing hard here. And once you have this, now you just apply this back to your raw stitch image, and just apply that to your raw stitch image, and voila, you have your final stitch image. So this will be the final stitch image. So basically we apply this rectangle that we found onto that image, and now it's excluded, successfully excluded those black points that we had at the edges. And if you compare this image to any of this input, you see that you have more information, because basically we are sort of like merging information across 3 images to find this last one. So that's how you go from inputs, images, the overlapping, the share overlapping view. Again, I forgot to mention that they must have overlapping view. So here we have this, we could clearly see this feature here, we could see this feature here. If you don't have overlapping view, then you cannot sort of find correspondence, that you cannot detect features across the images. So you want to see, for example, we have this cloud here, we have this cloud here, they look similar. We could easily know that this point matches this point. We have human beings here, we don't have this human being working here, but we have this guy here and we have this guy. So based on that, I also have this one white capping close to the shore here, or the shore rather, that is also present here. So with these many features that are similar in the two images, it's able to detect them and match them, and then find the extrinsics, align them, and once it's aligned them, then it could stitch them together. So that's how you match two images. I hope this was helpful. Please like and subscribe for more videos. And if you have any project you're working on, or you have any ideas of what you want me to make videos on next, please feel free to drop it in the comment section. I will definitely work on it. Again, this code will be available on my GitHub, because I have not reached some conditions on YouTube that they would allow me to put link directly. So I will put in the link, but I will drop out some of the dots. So if in case the link doesn't work, just look out there, because I will be missing out some dots somewhere. But if you like this video, if you comment on this video, if you share this video, and then I happen to get 1,000 subscribers, then I'll keep bypass that sort of challenge. So please, your like, your comment, and share would definitely help me get to overcome those restrictions that I have. So thank you so much again for spending time to watch through this video. If there's anything that you feel that I should include in this video that would have made it more informative or useful for other people, please drop it in the comment again. I'll be happy to go through and learn on how and work on how to improve this passing of this information across. Thank you again. Until next time, have a good day.